Hello everyone, my name is Ray O'Day and today I will be presenting on build automation in software engineering from manual builds to CI/CD. So this presentation focuses on how developers automate the process of building, testing, and deploying software and why that has become such an essential part of modern development. So I'll walk through what build automation is, why it matters, the tools involved, and how everything connects into a working pipeline. First, let me start with a quick scenario. Imagine you're working on a project, and every time you make a change, you have to manually compile the code, run tests, check for errors, and prepare it for release. Now imagine doing that dozens of times a day. It would be repetitive, time-consuming, and very easy to make mistakes. So here's the question. What if all of that could happen automatically? What if you could just write your code, push it, and have a system handle everything else for you? Well, that's exactly what build automation does. It removes repetitive manual work and replaces it with a reliable automated process that runs the same way every single time. And that is what we will explore today. So here's a quick overview of what I'll cover exactly within the presentation. First, I'll explain what build automation actually is and what it includes. Then I'll talk about why it's important in real-world software development, especially for teams working on large projects. After that, I'll introduce some of the common tools used for automation and explain how they fit into the workflow. I'll also walk through a simple example of a build pipeline so you can see how everything connects step by step. And then finally, I'll wrap up with a summary and a few key takeaways. So what is build automation? Well, build automation is the process of using tools to automatically perform the steps required to prepare software for use. These steps typically include compiling the code, running tests, packaging the application, and sometimes deploying it. In a manual process, a developer would need to run each of these steps individually, which takes time and increases the chances of mistakes. With build automation, all of these steps are combined into a single automated workflow. For example, instead of typing multiple commands, a developer can just trigger the entire process with a single action, like pushing code to a repository. This makes the development process much faster, more consistent, and much easier to manage and maintain. Now with that, why does it matter? Build automation is important because it directly improves how efficiently software is developed. First, it increases speed. Tasks that used to take a long time can now happen almost instantly. Second, it ensures consistency. Every build runs the same way, which means fewer unexpected issues are caused by human error. Third, it helps catch errors early. Automated tests can detect problems as soon as code is added, instead of later in the process. And finally, it supports scalability. As projects grow larger and teams grow bigger, automation makes it possible to manage complexity without slowing everything down. In short, build automation allows developers to focus more on coding and less on repetitive tasks. Now, there are several tools that help implement build automation. Some popular ones include Maven, Gradle, Jenkins, and GitHub Actions. Maven and Gradle are commonly used to manage builds, especially in Java-based projects. They typically handle tasks like compiling code and managing dependencies. Jenkins is a popular automation server that allows developers to create and manage build pipelines. Finally, GitHub Actions provides built-in automation directly within GitHub repositories. This makes it easy to trigger workflows when code is pushed. Each of these tools play a role in automating different parts of the development process, and they are often used together. This leads into the concept of CI/CD, which stands for Continuous Integration and Continuous Deployment. Continuous integration means that whenever code is added or updated, it is automatically tested and merged with the main project. This helps ensure that any changes, updates, or alterations made to the code does not break the system. Continuous deployment takes it a step further by automatically releasing the application after it passes testing. Together, CI and CD form a pipeline where code moves smoothly from development to production. This pipeline is one of the most important applications of build automation because it connects all the steps into a single continuous process. So let's walk through a simple example of how a build automation workflow works. First, a developer writes code and pushes it to a repository. Then, that action triggers the automation system. Next, the system compiles the code and checks for any syntax errors. After that, automated tests are ran to verify that everything is working correctly. If all the tests passed, the application is packaged and may even be deployed automatically. If something fails, the system reports the issue so it can be fixed quickly. This entire process happens automatically, which saves time and ensures reliability. Now, build automation offers many advantages, but it also comes with some challenges. On the positive side, it significantly speeds up development and ensures that builds are reliable and repeatable. It also reduces the amount of manual work developers have to do. However, setting up build automation systems can be complex, especially for beginners. There's also a learning curve when it comes to understanding the tools and configuring the pipelines correctly. But despite these challenges, most development teams find that the benefits far outweigh the difficulties, especially as projects grow in size and complexity. Now, in my opinion, build automation fundamentally changes how developers work. Instead of spending time on repetitive tasks like running builds and tests manually, developers can focus on writing better code and solving real problems. Automation also creates a more continuous workflow, where feedback is immediate and improvements can happen faster. This leads to much more efficient development and higher quality software. Overall, build automation is not just a tool, it's a shift in how software development is approached. To summarize, build automation is the process of automating tasks like compiling, testing, packaging, and deploying software. It improves speed, consistency, and reliability in the development process. Tools like Maven, Gradle, Jenkins, and GitHub Actions make this automation possible. CI/CD pipelines connect everything into a continuous workflow from development to deployment, and overall, build automation is essential for modern software engineering. These are the sources I used for this presentation. The information primarily comes from official documentation and resources for the tools discussed, including Maven, Gradle, Jenkins, and GitHub Actions. Reviewing the official documentation helped ensure that the concepts and workflows presented are accurate and reflect how these tools are actually used in real-world development. Now, beyond just researching, my understanding of build automation really came from applying these concepts while working on projects. Seeing how automated builds, testing, and pipelines work in practice made it much easier to understand how everything connects together. Overall, build automation makes software engineering processes faster, easier to manage, and personally, much more enjoyable to work with. Thank you for listening.